Hello all, my name is Richard Nugent. I'm an economist and the lead developer for the HEC program at HEC. This series of videos serves as an introduction to the derivation of uncertainty around the stage-damage relationship. In this video, we'll focus on the sources of uncertainty around residential structure and content value. Let's take a more detailed look at what goes into the uncertainty around the value of residential structures. There is uncertainty in the number of structures and the type of structures in the floodplain, as errors are possible in identifying structures and in classifying structures. There's also uncertainty in the depreciated structure replacement value. This could come about from errors in real estate appraisal, errors in estimation of replacement cost, estimation effective age, errors in estimation of depreciation, and errors in estimation of market value. The uncertainty about the depreciated replacement value of contents may be due to errors in the content inventory survey or errors in estimates of the content structure value ratio, depending on the approach for estimating the value of contents. With the latter method, the uncertainty about the value of contents is closely tied to the uncertainty about the value of a structure. That is, if we use a content to structure value ratio to determine the value of contents and think that there's actually some range of values in which lies the true structure value, that means that there is a range of values in which lies the true content value. Then, adding in the uncertainty around the actual ratio potentially adds to this range. When we measure the value of a structure, we care about the depreciated structure replacement cost. This cost represents how much it would cost just to replace the structure in the structure's current condition. We do not include the value of the land on which the structure resides. The depreciated structure replacement value can be measured directly or indirectly. We'll go through the sources of uncertainty from either method of measurement. Methods of direct measurement of the depreciated structure replacement value include Marshall and Swift residential and commercial estimators, or other similar cost estimators such as RS means. There are advantages of this method, including that the method is replicable, computerized, and has only moderate data needs. Potential sources of error include potential measurement error in variables, such as error in measuring the size of the structure, the basement finish, the class, construction, and there is a subjective judgment involved, such as determining the effective age, which impacts the depreciation estimate, and identifying the construction quality. These things are subjective, not objective measures. Methods of indirect measurement of the depreciated structure replacement value include real estate appraised value, market value, which comes from recent sales prices, or an assessed value from a tax assessor's database. All of these methods require adjustments to the primary data to get an estimate of the depreciated structure replacement value. Potential sources of error that could result from the indirect method include error measuring the depreciated structure replacement value, and this could depend on the method, the separation of the real estate value into land and improvements, and the adjustment for bias and/or statutory limitations in value. There is one possible advantage over the direct method, and that is the availability of this kind of data. Let's take a look at an example of direct measurement of the depreciated structure replacement value. The characteristics in the table on this slide have been collected for a structure and are linked to Marshall and Swift. A combustible construction square structure of average quality at 1,200 square feet that is 25 years old with an unfinished basement A detached one-car garage and front porch is estimated to have a depreciated structure replacement value of $52,000. $52,000 is the best estimate or most likely value. Let's consider an example of all similar Class D wood frame single-family residential structures. We may see a distribution of depreciated structure replacement costs in the inventory, such as the distribution is represented by the histogram on this slide. We want to characterize this distribution. We're looking at similar Class D wood frame single-family residential structures and can characterize the distribution of structure values with variation in the quality parameter through the price per square foot. For example, a good quality price per square foot may be $43, and this represents the most likely value. The minimum may be $25, and the maximum may be $57. We can use these parameters together with at-risk's Monte Carlo procedures to fully characterize the distribution of depreciated structure replacement value. From at-risk, we are particularly interested in the coefficient of variation, which is a measure of uncertainty, or standard deviation, relative to the mean for each structure type. On the right is the fleshed out distribution of depreciated structure replacement value with a minimum of $30,000, a most likely of $52,000, and a maximum of $68,400. Methods for quantifying content values include using content to structure value ratios. Some sources for content to structure value ratios include using generic content to structure value ratios, site-specific ratios, or drawing from flood insurance administration records, either site-specific or national level records. Direct estimates are also an option, and we can draw from the inventories or carry out random or stratified sampling methods to determine content values. Methods for quantifying the uncertainty around the content to structure value follow the method used to quantify the actual ratio or value and typically look like characterizing the sampling distribution, but can also take the form of expert elicitation, in which case a triangular distribution may be most appropriate. Here is an example of a representation of the uncertainty in the content to structure value ratio. Observe that the content dollars per square feet for different structure types are represented using different triangular distributions. If you have any questions, please feel free to email me, Richard Nugent, or post your questions to the discourse discussion board. Thank you.